Hello everyone and thanks for watching Edupedia World videos. I am Manish Agrawal and today we'll continue with the topic of mole concept. If you remember, in the last session we studied the concept of gram atomic mass and gram molecular mass. Today we'll solve some numerical problems on the same. Alright. So let's first revisit the formula that we studied in our previous sessions. First formula that we studied was for number of moles of molecules. We studied that number of moles of molecules is equal to given mass of a substance divided by gram molecular mass. Alright. Here we have to note that we are talking about moles of molecules, not number of molecules. Alright. So number of moles of molecules is equal to given mass divided by, since we are talking about molecules, we use gram molecular mass, not atomic mass. Okay. The next formula that we studied was for number of moles of atoms. So in this case it will be given mass divided by gram atomic mass. Okay. So given mass divided by gram atomic mass gives us moles of atoms. And we already know that number of moles is same as number of gram particles. Okay, gram particles is just another way of writing moles. Okay, once again we are not talking about gram of particle. Okay, not number of grams of particle. We are talking about gram particle. It is one single word. Okay, it is hyphenated. Number of gram particles. So it is one phrase. And another formula, number of moles or number of gram particles can also be calculated as number of particles divided by Avogadro's number. Okay, once again, see, in the sessions before this we always used unitary method to calculate such questions. Okay, for example, I told you that one molecule of ammonia, or say one molecule of CO2, carbon dioxide, one molecule of CO2 has 2 atoms of oxygen. So we calculated 1 mole will have how many? 2 moles of oxygen atom, and similarly 1 dozen will have 24 atoms of oxygen. So we used unitary method. Okay, so instead of always using unitary method, you can always use this last formula. Number of moles or number of gram particles can be calculated using the formula number of particles divided by Avogadro's number. Okay, this is just a result of cross multiplication of the unitary method. Okay, so you can directly remember the formula or use the unitary method if you are comfortable with that. So number of particles divided by Na will always gives us number of moles of that particles. For example, if you have 10 atoms of nitrogen, then 10 divided by Avogadro number would give you number of moles of atoms of nitrogen. If you have 10 molecules of nitrogen, then 10 molecules divided by Avogadro's number will give you number of moles of molecules of nitrogen. Okay, so now let's move on to the examples, the calculation part. So let's look at our first example for today. You have to calculate, if you have been given 16 gram of methane, then you have to calculate number of gram molecules of methane. Okay, so you have been given mass of methane. First you need to know the molecular formula for methane. Okay, so what is methane? Well, methane is CH4. Okay, let's shift this a bit. So methane is CH4. Okay, so it has one carbon atom. In one molecule it has one carbon atom and 4 hydrogen atoms. Together they combine to form one molecule of methane, that is CH4. So when I say I have 1 mole methane, it implies that I have 1 mole carbon atoms, that is 1 mole of C, and I have 4 moles of hydrogen atom, that is 4 mole of H. Okay, so I have 12 gram carbon plus 4 into 1 gram hydrogen. Alright, what am I doing here? I am calculating the molecular mass of methane. Okay, so if you remember molecular mass or molar mass, okay, it is mass of Okay, from now on we'll be concerning ourselves with gram molecular mass. Okay, so like in your books, when we usually say molecular mass, we'll basically be referring to gram molecular mass. So for CH4, 1 mole has weight of 12 gram plus 4 gram, that is 16 gram. Okay, so this is the gram molecular mass of methane. Okay, because carbon has a gram atomic mass of 12 gram and hydrogen has gram atomic mass of 1 gram. So there are 4 atoms of hydrogen, so 4 into 1, plus there is only 1 atom of carbon, so that is 12 gram. So 12 plus 4 is 16 gram. So 1 mole methane weighs 16 gram. This is the gram molecular mass or molar mass of methane. So let's see what our question asked us to do. So it said that given 16 gram of methane, see now the given mass is also 16 gram and gram molecular mass is also 16 grams. So we have to calculate number of gram molecules of methane. That is nothing but number of moles of methane. So you have to calculate number of gram molecules. So that is number of moles. Okay, is equal to number of gram molecules. So that number of gram molecules and number of moles is equal to given mass. Okay, we already know the formula. It is equal to given mass, okay, divided by gram molecular mass. So given mass is the mass given in the question, given 16 gram of methane. Alright, so 16 gram divided by gram molecular mass. Gram molecular mass is what we calculated here. It is again 16 gram. So 16 divided by 16, that is 1 mole. Okay, so number of moles or number of gram molecules of methane is 1 mole. So this answers our first part of the question, that number of gram molecules of methane is 1 mole. Next part of the question, what is the number of moles of atoms of carbon? Okay, so again CH4, we just saw that 1 molecule of methane has 1 atom of carbon. Okay, so 1 molecule of methane has 1 atom of carbon. This implies 1 mole CH4 or 1 mole molecule of methane will have 1 mole atoms of carbon. Alright, so 1 mole of methane will have 1 mole of carbon. So 16 gram of methane is equal to 1 mole of methane, hence it is equal to 1 mole of carbon. So 16 gram of methane has 1 mole of carbon atoms. Alright, last part of the question is number of atoms of hydrogen. Okay, so last part of the question is we have to calculate number of atoms of hydrogen. So let's see how we can do that. So to calculate number of moles of hydrogen, we'll solve it over here. So we have CH4. So again CH4, 1 molecule of CH4 has 4 atoms of hydrogen. Okay, 1 molecule of CH4 has 4 atoms. So 1 mole methane has 4 mole hydrogen. 1 mole methane has 4 mole of hydrogen atoms. So this implies 16 gram of methane was 1 mole. So 16 gram of methane has 4 moles of hydrogen. You don't have to calculate moles of hydrogen. You have to calculate moles. You have to calculate atoms of hydrogen. Okay. So you have to calculate atoms of hydrogen. So let's use the formula for once. Instead of unitary method, let's use the formula. So we know that number of moles of atom is equal to number of atoms divided by Na. Okay, this is the formula we studied today. Okay, in the first slide, that number of moles or number of gram particles is equal to number of particles divided by Avogadro's number. So you know you have 4 moles of hydrogen in the question. Okay, you already know that you have 4 moles of hydrogen in the question, and you have to calculate number of atoms of hydrogen. So from the formula we can directly calculate. Just substitute the value. 4 is equal to, let's say, number of atoms is n divided by Avogadro's number, which is 6.022 into 10 to the power 23. Okay, so our answer will be n divided by this is equal to 4. So n is equal to 4 into 6 is 24. Okay, so 2.4088 into 10 to the power 24 atoms of hydrogen. So these many atoms of hydrogen are present with you. Okay, so this is the last part of the question. Okay, so that solves all our 3 parts. First part said answer was 1 mole or 1 gram molecule of methane. Second part, 1 mole atoms of carbon, and last part 4 Na atoms of hydrogen. That is these many, 2.4088 multiplied by 10 to the power 24 atoms of hydrogen. Okay, now let's look at another example. Okay, we'll have to use the same formulas again. Okay, because those are all we have studied till now. So let's look at example 2. In example 2, you have to calculate mass inside a container. Okay, now the container, there are 3 separate containers. Okay, and you have to calculate the mass inside in each of those container. In the first container, you have 2 moles of oxygen gas. In second, you have 4 mole of nascent oxygen, and in third, you have 4/3 mole of ozone gas. Alright, so let's look at what the situation is in the question. So in the first part, you have one container. Okay, you have one container containing 2 mole of oxygen gas. Okay, what is oxygen gas? Oxygen gas is O2. Alright, if you remember, oxygen gas is O2. Okay, in the second part, you have another container in which you have 4 mole of nascent oxygen atom. Okay, nascent oxygen atom means you just have oxygen atoms. Okay, nascent oxygen atoms, you have to remember this term. Nascent oxygen atom means you just have oxygen atoms. It is not in the form of molecules. It is not in the form of O2. Okay, so you have 4 mole of O. Okay, and in the last container, you have 4/3 mole of ozone gas. So we already know what ozone is. 4/3 mole of O3. Okay, so in each of these cases we have to calculate the mass inside the container. So we already know the formula which we have to use here. Okay, what's the formula? We know that number of moles is equal to given mass divided by gram molecular mass or gram atomic mass, depending on what is given in the question. Alright, so let's see. Okay, let's calculate the first part first. So 2 moles of oxygen, you know that number of moles. Okay, let's say number of moles is n. So number of moles is equal to given mass, that is W, divided by gram molecular mass of oxygen, that is O2. So number of moles given to you in the question is 2. So 2 is equal to mass inside the container, that you have to calculate, say W, divided by gram molecular mass. Gram molecular mass of oxygen is 16 plus 16, or 16 into 2 is equal to 32 gram. Okay, gram molecular mass of oxygen is 32 gram. So W divided by 32. So W is equal to 64 gram. Okay, so the mass inside the container is equal to 64 grams. So that's our answer for the first part. Let's look at the second part now. In the second part, you have 4 mole of oxygen atom. So you have atoms this time. So what you will use is number of moles of atoms is again equal to mass, given mass divided by gram atomic mass. Okay, and gram atomic mass of oxygen is, you already know that gram atomic mass of oxygen is 16 gram. Okay, that's just one atom O. So number of moles 4 is equal to given mass W divided by gram atomic mass 16. So W comes out to be 4 into 16, that is again 64 grams. 4 into 16 is again 64 grams. Alright, for the last part you need to know gram molecular mass of ozone. So gram molecular mass of ozone is 16 into 3, because in one molecule there are 3 atoms, so that is 48 grams. Okay, so gram molecular mass of ozone is 48 gram. Again, use the same formula as we used in the first part. Number of moles of molecules is equal to given mass divided by gram molecular mass. So number of moles is equal to 4 by 3. Given mass is what you have to calculate, let's say W, and gram molecular mass you know is 48. For ozone, gram molecular mass is 48. So W comes out to be 4 by 3 multiplied by 48, that is again 64 grams. Okay, so you see the answer for each part is 64 grams. 64, 64 and 64. So 2 mole of oxygen atoms, 2 moles of oxygen molecules is equal to 4 moles of oxygen atom is equal to 4 by 3 mole of ozone molecules in terms of mass. Okay, so that answers our question completely. So now you have to start getting a feel of this formula and these questions. Okay, how we are solving them, how we are substituting the values. Alright, let's look at another example and let's see if you can think of the answer yourself. So in this question you have 17 kilogram of ammonia gas. Okay, you have 17 kilogram of ammonia gas which is mixed with 14 kilogram of nitrogen gas, and now you have to calculate whatever you have to calculate in the question. Okay, first let's analyze what you have in the container. Okay, you have a closed container. You have a closed container in which you added 17 kilogram of ammonia. Okay, then you brought 14 kilogram of nitrogen and you kept them inside this closed container. Okay, so 17 kilogram is 1 kg is 1000 gram. Okay, since we are always dealing with gram, let's convert the masses into gram. So 1 kilogram is 1000 gram. This implies you have 17,000 gram ammonia and you have 14,000 gram of nitrogen gas. Okay, so you have two different gases inside the container. Okay, and you know the mass of each of those gases present inside the container. Now you have to calculate number of moles of nitrogen atom as well as number of nitrogen atoms inside this container. Okay, so you have to calculate two different things. First you have to calculate total number of nitrogen. First you have to calculate total number of moles of nitrogen atoms, and you have to calculate number of nitrogen atoms. Okay, so you have to calculate number of moles of nitrogen atom, and in the second part you have to calculate number of nitrogen atoms. So you have mass and you have to calculate moles. So how do we do that? We use the formula. Okay, what formula? You need to know the gram molecular masses first. So gram molecular mass of ammonia is NH3. Alright, ammonia gas is NH3. So gram molecular mass of ammonia is 14 plus 3. Okay, 14 plus 3, that is 17 gram. Gram molecular mass of ammonia is 17 gram. 14 gram is the atomic mass of nitrogen and 1 gram is the atomic mass of hydrogen. Since you have 3 atoms of hydrogen, what you did was 3 into 1, that is 3 gram. So 14 plus 3 gives you 17 gram of ammonia. Okay, similarly you have gram molecular mass of nitrogen gas N2, that is 14 into 2 is equal to 28 gram. So gram molecular mass of nitrogen is 28 gram because it has 2 atoms of nitrogen and 1 atom of nitrogen weighs 14 gram. 1 mole atom of nitrogen weighs 14 gram. So 2 moles will weigh 28 gram. So gram molecular mass of nitrogen is 28. So to calculate number of moles of nitrogen, what you have to do is, first you have to calculate number of nitrogen atoms or number of moles of nitrogen atom due to this compound. Okay, first you have to calculate number of moles of nitrogen atom present in ammonia. Then you have to calculate number of moles of nitrogen atoms present in N2 and you just simply add them. Okay, you simply add these 2 moles, so you get the total number of moles of nitrogen. Okay, so let's look at the first part. Let's look at the answer for the first part. So first let's calculate moles of nitrogen atom in ammonia. So first let's calculate moles of ammonia. So moles of ammonia is given mass of ammonia divided by gram molecular mass of ammonia. You know given mass of ammonia is 17,000 gram. Okay, that's why you converted them into gram. 17,000 gram divided by gram molecular mass of ammonia is 17 gram. So 17,000 divided by 17 gives us 1,000. So you have 1,000 mole of ammonia in the container. Okay, you have 1,000 mole of ammonia in the container. Now if you look at the formula for ammonia, it is NH3. So you know that one molecule of ammonia has 1 atom of N or 1 atom of nitrogen. Okay, it means 1 mole ammonia, it means that 1 mole ammonia will have 1 mole nitrogen atom. Okay, and it means that 1000 mole ammonia will have 1000 mole of nitrogen atoms. So the nitrogen atom from ammonia is 1000 mole. Alright, the nitrogen atom from ammonia is 1000 mole. Now let's see the number of moles of atom or number of moles of atoms of N from N2. Okay, so this is 1000 moles of nitrogen from ammonia. Now from N2, again we have to calculate moles of N2 first. Okay, again you have to calculate moles of N2, which is given mass divided by gram molecular mass. Given mass of N2 is 14,000 gram. Given mass of N2 is 14,000 gram and gram molecular mass of N2 is 28 gram. Gram molecular mass of N2 is 28 gram. So 14,000 divided by 28, that will be equal to 500 mole. So from here you have 500 mole of N2. Now again, you know that 1 mole nitrogen gas or 1 mole of N2 has how many atoms of nitrogen? 2. Okay, you can directly see one molecule has 2 atoms, so 1 mole molecules will have 2 moles of atom, so 2 mole nitrogen atom. So 500 mole of N2 will have how many? 2 into 500, that is 1000 mole of nitrogen. Alright, or you can write it as X and cross multiply, that is use unitary method. Okay, you can write 500 moles of N2 has X moles of N, and then cross multiply X into 1 is equal to 500 into 2. Okay, so you get X is equal to 2 into 500, that is 1000 mole of nitrogen. So you have 1000 mole of nitrogen atoms from N2, and you have 1000 mole of nitrogen atom from ammonia. Okay, so total number of moles of nitrogen atom which you have to calculate in the first part, number of moles of nitrogen atom, will be sum of these two. Okay, will be sum of these two. So we can directly say that number of moles of nitrogen atom is equal to 1000 plus 1000, that is 2000 mole of nitrogen atoms are present inside this container. Okay, in the second part you have to calculate number of nitrogen atoms. In the second part you have to calculate number of nitrogen atoms. You have been given moles of nitrogen atom. Okay, from the first part we have moles of nitrogen atom, and from there we have to move on to number of nitrogen atom. Let's say it is equal to n. So we know that number of moles is equal to number of particles divided by Na. Okay, we can use unitary method or we can directly use the formula. So number of moles of nitrogen is 2000, number of atoms is n divided by Avogadro's number. Okay, this implies n is equal to 2000 into Avogadro number. Okay, 2000 into Avogadro number, which will be 1.2044 multiplied by 10 to the power this time 27. Alright, this will be your answer for the second part of question, that number of atoms of nitrogen is equal to 1.2 into 10 to the power 27. Okay, that is 2000 mole for the first part and those many for the second part. So until next time, okay, and for the next session we'll continue with the mole concept obviously, but we'll study a new subsection in the mole concept. Alright, so once again thanks for watching Edupedia World videos and good luck.